Washington State University. Go Cougs!
Hello and welcome to Module 2 of our course on collecting smartphone sensor data using iOS. In Part 2 of Module 2, we'll be looking at the Core Motion Framework. The Core Motion Framework is the main way in which we can access the accelerometer and the gyroscope data. To begin with, we need to import the Core Motion Framework into our code. So in this next slide, we see a portion of the viewcontroller.swift file from our sensor app. And you can see at the top here, we're importing the Core Motion Framework. So that will give us access to the various methods and functions. The second step is to create an instance of the Core Motion Manager. And that is the main class object which we will use to call the various methods to access the sensor data. As part of the initialization of the Motion Manager, we need to set the update interval, which is how often are we going to sample the sensors. So back in the code, you see we've created this function called initialize motion, and in there we're creating the Motion Manager, and then we're telling it what the update interval should be, in this case 10 times a second. Now this should only be done once for our app, so we'll be calling it from the viewDidLoad function, which is the first function that's called when our view loads up. The next step is to start up the updates, and we'll tell the Motion Manager where we want this data to be sent, and that will be our handler. So the Motion Manager will call this handler 10 times a second, and it will pass in one of these Core Motion device motion objects. Now that is the main object that contains all of the data from all of the sensors. And there's various ways we can access the sensor data. We could access the raw accelerometer and gyroscope data, but there are other ways that we can access it. In particular, we're going to be using the user acceleration property of the device motion object. And the nice thing about this property is that it removes gravity from the accelerometer data. That way we know just the movement that the user is imparting to the device minus the gravity. Likewise, instead of the raw gyroscope data, we'll be using the attitude property, which will give us the yaw, pitch, and roll that the user is imparting to the device, removing other things like gravity and Earth's rotation and other factors that can pull on the device. And then finally, the Motion Manager provides a way to stop the sensors. In general, it's a good idea to stop sensors when you're done using them because they do use a lot of power, and if you leave them on all the time, that will drain the battery. Now this just scratches the surface of the Core Motion Framework. I provided a reference down here to Apple's documentation, which provides all of the details, so you can take a look if you want to see what else can be done. All right, so let's take a look at the code that we're going to add to our sensor app, and then we'll go ahead and add it and try it out. So we already talked about the this initialize motion function. Notice that we're creating a variable Motion Manager of type Core Motion Manager. We're making it a explicitly unwrapped variable because it should always be there. And jumping down to the stop motion updates, that's just a simple call to the Motion Manager to the stop device motion updates method. So that will stop the sensors and the calls to our Motion Manager, or to our handler, sorry. And then we'll create this function called start motion updates, and that will call the method start device motion updates of our Motion Manager. And that takes two arguments. The first argument is the queue or the thread that will run the motion updates. And the second argument with handler is the function that we will write to handle the sensor data. Now, I won't go into detail about queues and threads, but just to briefly state that the main queue is the queue that the view is updated on. So the app is using the main queue to update your view. And so generally we don't want to add too much work to that queue because we don't want our view to slow down. We don't want it to become unresponsive. So in our case, we're only updating 10 times a second, so it won't be that much of a burden on this main queue. But if we were wanting updates, say 100 or 1,000 times a second, we may want to create a new queue that will handle that extra workload. So if you are wanting more frequent updates, then you probably want to take a look at how to create a new queue and run the updates on that queue. But for now, we'll be using the main queue because, again, we won't be adding too much extra work to it. Now let's take a look at this motion handler. Again, that's up to us to write. The motion handler takes two arguments. One is this device motion object we described before, and the other is an error. Notice these are both optional variables, meaning they could be nil or actually have a value. So to handle those two possibilities, we'll be using that optional chaining technique within the if then else structure. So first we'll check and see if there are any errors. So we use this if let, and then we create a new local variable called ERR, which will be set to the error if it in fact contains a value. If it doesn't contain a value, meaning the error is nil, which is good, we don't want an error, then this if statement will evaluate to false and will go down into the else part. But if there is in fact an error, then this ERR variable will be set to the actual error. And in this case, we're just printing it out to the console, and we're using this special localized description property of the error, which takes into account the user's preferred language. Now, if there is no error, the error is nil, then we'll come down to the else part. And again, we'll use the optional chaining to decide whether the device motion data is nil or whether it's actually there. And if it is there, it will be set to this local DM variable. Now, if device motion is nil, then this if will evaluate to false, and then we'll fall down into the else part, and again, just print out a message to the console to let us know about that. But if the device motion data is available, then we're simply calling another function that we'll write to display that information on our view. So let's take a look at that method. So the process motion function will take a device motion object, and we know it exists at this point. And then we'll be accessing those two properties we mentioned, the user acceleration, X, Y, and Z, and the attitude, pitch, roll, and yaw. And once we have those values, then we will update our text or our labels on the view with the appropriate string with the floating point values of our sensors inserted into those strings using this / parenthetical approach. Okay, so that's the code that we need to add. So let's actually go into Xcode and add that code in. So I'm going to go back to this part, escape out of PowerPoint, and copy the variable definition and the three methods here. And I'll go into Xcode and we'll load in our sensor app. Okay, recall in the last part we just added our privacy, our reason for accessing the data. I'm going to go into the view controller, and then up at the top I'm going to import core motion. And then down here just above the view did load, I will add in that extra code. Actually, I like to put my variables up at the top, so I'm going to grab that, put it right up at the top. Okay, so we see that we have an error here because we haven't created our motion handler yet. We'll do that in a second. But you might remember from the notes that where we wanted to call these various functions. So the initialize motion we want to call from view_did_load. So down here in the view_did_load, I'm going to go ahead and call my initialize motion function. And then to start the motion updates, we'll do that when the start button is tapped. So I'll add start motion updates there. And then to stop the motion updates, we'll do that when the stop button is tapped, which is this stop tapped function. Okay. So next we'll define our motion handler. So let me go back to the slides and we'll go to the next slide and I will grab the code here for the motion handler and I'll go ahead and put that right below where we call it. Okay, so our first error is gone. The second error, or the new error now, we need our process motion data function. So back to the notes, and I'll get that. Notice we're calling this version 1 full precision. Grab that comment too. I'll show you a different version of that in a second. So let me put that code in. And that should do it. So that should start the motion updates and display them on the view. Now we come to rather one of the unfortunate parts of Xcode, specifically in the simulator, and that is if we run this, we will see that the motion values are not updated, and that's because the simulator does not simulate the accelerometer or the gyroscope. So I can bring up the simulator view. So first we'll just make sure that it loads correctly. Okay, so there's our view, and you'll notice if I hit start, it says sensor started, but we're not getting anything. Again, that's because the simulator does not simulate the gyroscope or the accelerometer. So this is a case where you actually need to run this on a real device. And I've already showed you how to do that just by, of course, connecting a device to the Mac you're developing on and then choosing it from the scheme up here and running it. Now I took the liberty of already doing that and took a short video of that. So let's go back to the notes. Let me stop the simulator. So if we go to this next slide here, again, just noting that the simulator does not have the gyroscope or the accelerometer sensors simulated, so we have to use a real device. So here's a movie of my running it on a real device. So we click the start button and the sensors are going. So there we see our values in their full precision being displayed. We hit the stop button, they'll stop. And then, of course, if we hit start again, they'll start back up. So there's what your sensor app should look like at this point. But one thing about this is that this is quite a bit of precision, and we may not want to display all of those decimal values because, for one, it kind of clutters up the screen and we may not even need that much precision. So that brings us to the version 2 of our process motion data. And here all we're doing is we're formatting the floating point that comes back from these various sensor values. Now we're doing that by converting them to a string in this case, but this string has a particular format, and you may be familiar with these types of formatting strings, especially if you're a C or C++ programmer. But what this basically means is the %f means that we want to create a string from a floating point number. But if we put the .3 in the middle of it, that says that we want 3 decimal places after the decimal point. If we wanted 5, we could put a .5 there. So I'm going to add this code into our app to get these values to print out a little prettier. So let me grab this code, and then we'll go into Xcode, and I'll replace version 1 with version 2. And once again, now we have our formatted strings. So again, I could run this in the simulator, but it wouldn't do anything. So let me go back to the notes and show you a short clip of this version 2 app running. Okay, let's start that up. So now when we start the app or the sensors, we see that they're precision of 3 decimal points instead of across the screen. So if you wanted less precision, then that's how you can format it a little differently. Okay, well that's our overview of the core motion framework, and now we have our motion sensor data displaying to the screen, and we saw the updates to the app to accomplish that. In the next part, we'll be doing similar things in order to access the location sensors.